Hey everybody, this little video lesson is a tutorial on what to do when you see a bunch of naming problems and they're all mixed up between ionic, ionic with transition metal, and covalent. We'll also talk about how you do the same thing when you're writing out the formulas. Let's talk about the mixed up naming situation, because this is very much like what you're going to do on an upcoming quiz and test, where I'm not going to tell you exactly how to name each one of these. I've taught you how to name each one individually, but you're going to have to look for clues in the formula to figure out how you're going to name these substances, whether or not they're ionic, keeping an eye out for transition metals, or even using prefixes when naming covalent. Here are the three examples that I'm going to use. I added those to the left-hand side of this. And on the right-hand side, I'm going to talk about the little clues that you'd use in each case. Because when you look at each one of these, they could be ionic, an ionic with a transition metal, or covalent. Now, let's just be clear that these don't match with the ones directly across from it. These could be any one of these options over here. Now, when it comes to ionic, just a regular old ionic, the first thing you look for is that the first element is a metal. If the first element is a metal from group 1 or group 2 or aluminum, then it's just a regular ionic. Now, ionic with transition metals are, well, just that, ionics with transition metals. So you look for any of those metals buried in the middle of the periodic table and a little bit under the stairs, things like iron or tin or lead or even copper or nickel. Those are all transition metals. Now, what makes ionic with transition metals different than ionic is that ionic with transition metals need to use the Roman numerals in the name, but ionics, just regular, don't use the Roman numerals. And finally, covalents are the only type that use prefixes in the name. No Roman numerals, just prefixes. Now I come up to a set of problems like you see on the left-hand side of the screen here, and I need to start trying to figure out how to name these. Well, the first thing I do is I go through each example and I put an I for ionic next to the ones that are just regular ionic. I put a T for transition metal next to any that are ionic with transition metals, and I put a C for covalent next to any of those that are covalent. That way, I know right away which ones are ionic, transition metal, and covalent. And then maybe I just tackle all of the same type right away. I put all the regular ionics and I just get into the ionic mode and I just start naming those regular ionics and just do all of those. Then I do all the covalents, and then I save all the transition metals to last. It's really up to you. But the first thing I do would be to name or label them as I for ionic, T for transition metal, or C for covalent. And I usually do that right down the left-hand side of the problem right here. So I look at this first one, and I see that it's got calcium in the first. Well, that's just a regular ionic, so I'll label that I here next to the calcium. The next one down is carbon with oxygen. Well, carbon is a nonmetal, and that means that it's covalent, because remember, covalents are nonmetals bonded to nonmetals. Finally, the last one, I look and I see iron is a metal, but it's not just any metal, it's a transition metal. So I will label this with a big T out front. Now that I have them labeled as ionic, covalent, and transition, I can then go over to each one of these and say, all right, all my regular ionics, no Roman numerals. And all of my covalents, just make sure I use the prefixes, but no Roman numerals. And all my transition, I need to do Roman numerals. And so here are the answers. This first one is calcium phosphate. No Roman numerals, no prefixes. The second one, because it's covalent, uses prefixes. It's dicarbon pentaoxide. And finally, this last one, because it's a transition metal, needs Roman numerals, but no prefixes. I say this is iron 3 chloride, because the iron has a +3 charge. In summary, by identifying what type of naming I'm doing really helps me out so that I can focus in on what it needs and what it doesn't need. What it needs, maybe Roman numerals, but what it doesn't need is prefixes. Or maybe it's a covalent and it needs prefixes, but no Roman numerals. You can basically break any naming down into these three types: regular ionic, transition metal ionic, or covalent. Let's shift gears now to mixed up writing practice. I'm going to go through the same process. I'm going to put up some names of some different compounds and talk about the three different types. Once again, those three types are regular ionic, ionic with transition metal, and covalent. Now let's talk about what makes each of them different. Now I look at the name and I read the name, and the name maybe has no Roman numerals and no prefixes in the name. Well, I know, because it has no Roman numerals and no prefixes, that it's just a regular ionic substance. And when it comes to writing, well, it's important that for all ionics, I balance the charges so that the formula is just right. Now, when it comes to transition metals, I know it's a transition metal ionic if I see a Roman numeral. If you see a Roman numeral, it's got to be transition metal. Transition metals, you always know the charge of the metal because that's a Roman numeral. And then you can figure out the charge of the nonmetal, or the anion, based on either the element's position in the periodic table, or if it's a polyatomic ion, you can check the back of your periodic table to decide what the charge is. But the key here is that you recognize it's a transition metal because there's Roman numerals in the name. Finally, if you see prefixes in the name, then it's got to be covalent. It's the only type that has prefixes. And if it does have prefixes, well, then you just write what you see. So if it's got a mono or a di or a tri, that just means it's how many there are, 1 or 2 or 3. So let's take a look at some of the examples that I've written down on the left-hand side of the screen here. Now once again, I'm going to identify each as regular ionic, transition metal ionic, or C for covalent. Now as I look, I see copper 1. Oh, that's a Roman numeral. Dead giveaway that I'm looking at a transition metal ionic. So I put a little T here next to this one. And maybe I find all the ones with a Roman numeral in them and identify them as T for transition metal. And then I go through and I find all the ones that have prefixes in them, like the second one, dinitrogen tetroxide. It's got to be covalent. So that's what I'm going to put here. I'm going to put a little C next to this one, and I find all the other ones with prefixes. And then anything that's not transition metal or covalent automatically becomes a regular ionic. But I double check. I look for no prefixes and no Roman numerals, but I can be assured that if it's not if it's not transition or covalent, it's got to be just regular ionic. So now that I've labeled each one, I can go back to my little clues and figure out how to name it. So maybe I'll just do the regular ionic first. Oh, no Roman numeral, no prefix. All right, let's just balance the charges. So you take lithium with a +1 charge and hydroxide, which is one of the polyatomic ions. It's one of the only polyatomic ions that doesn't end as an ATE. So you find it on the back of the periodic table. It's a -1 charge. Well, if you crisscross the charges, what you get is Li1OH1, or just LiOH. Now I go on and find my transition metal, also ionic, and I got to make sure that I balance the charges. And it's easy to know the charge of the metal because the Roman numeral is the charge of the metal. So copper, in this case, has a +1 charge. Now nitrate, that's an ATE ending. That's a dead giveaway that it's a polyatomic ion, and that is one from the back of the periodic table. It's NO3. Well, each of these have a +1, -1 charge, so those cancel each other out. So my final compound is CuNO3. Finally, the only one left is the covalent, and it has prefixes. So I just translate the prefixes into symbols and numbers. So dinitrogen, well, that's 2 nitrogens, N2, and then tetrachloride, that's 4 chlorines, so Cl4. And make sure that you don't reduce covalents. They have prefixes and they don't reduce. So the final compound is N2Cl4. Well, this is how you do writing and naming when they're all mixed up. I showed you some tricks on how to do this, and hopefully this will help you tackle this worksheet that you need to do for practice and hopefully do well on the upcoming quiz and test. Well, that takes care of this video lesson. Thanks for watching.